In this video, I want to talk about two very common types of questions about moles. These two types of questions don't really fit into the other categories we've talked about, but they show up all the time on homework, in textbooks, on quizzes, and particularly on tests and exams. Okay, here's the first one. What is the mass in grams of a single atom of oxygen? Okay, this is the type of question that asks us to calculate the mass of a single atom of some element. Here, we're going to use oxygen as the example. Now, in order to solve problems like this, we've got to pull in a few different pieces of information about moles, okay? The first one is going to be about mass, right? We're talking about the mass of a single atom of oxygen. What do we know about the mass of oxygen? Well, we can look up oxygen on the periodic table and we can zoom into this number, 16.00, which tells us the molar mass of oxygen. It tells us how much a mole of oxygen weighs in grams. So we can say that from this information on the periodic table, 1 mole of oxygen atoms weighs 16.00 grams. Okay. But we're not talking about a mole of oxygen atoms. We're talking about a single atom of oxygen, one oxygen atom. So what do we know about, say, like the number of oxygen atoms in a mole? Well, you may know that 1 mole of oxygen atoms contains 602 hexillion oxygen atoms, which we often abbreviate as 6.02 times 10 to the 23rd. Now, we want to combine these two pieces of information to make a third piece of information. Okay, check this out. We know two things here. On the one hand, we know that 1 mole of oxygen atoms weighs 16.00 grams. And we also know that 1 mole of oxygen atoms contains 602 hexillion oxygen atoms. So we can combine these two pieces of information to say that 602 hexillion oxygen atoms weigh 16.00 grams. Okay? We can even take this and express it kind of as an equation, kind of as a relationship here, and we can say 6.02 times 10 to the 23rd oxygen atoms equals or is equivalent to 16 grams. Now check out this last thing that I drew, okay? This thing here is an equation, a relationship that we can turn into a conversion factor that will let us go from the number of oxygen atoms we have to grams. Okay? So I'm going to use this equation as a conversion factor to go from 1 oxygen atom to a certain number of grams. Here's how I'm going to do it. Let's start here. I'm going to do 1 oxygen atom. And now I'm going to multiply that by a conversion factor made from this relationship. I want to get rid of oxygen atoms, which is on top here. So I'm going to write this relationship as a conversion factor with oxygen atoms on the bottom. Okay, so I'm going to take this part here. 6.02 times 10 to the 23rd oxygen atoms, put that on the bottom, and make my fraction here a little bit longer. And then I'm going to put the other side of the relationship, 16.00 grams, on top. And now when I work through the math here, oxygen atoms on the top, oxygen atoms on the bottom, they're going to cancel out, and that's going to leave me with grams, which is exactly what I want. I'm just going to rearrange this so we can go through the math. Okay, so you write this out. You probably want to solve it by putting it into the calculator. You can type it in like this, although you don't really have to multiply by 1 here, because multiplying something by 1 doesn't change its value, but it's totally up to you. You put this in, you're going to get this out as an answer. This e minus 23 in calculator language just means this times 10 to the negative 23rd. And then we're going to want to take this number and round it to 3 significant figures. We don't worry about the significant figures in 1 here because this is a counting number. We're saying 1 oxygen atom, it's not a measurement. So this has an infinite number of significant figures. We're going to round this to 3 significant figures because there are 3 in 6.02, which has the fewer number of significant figures. So we round this to 2.6. We have the 5 here. We round it up because of the 7. 2.66 times 10 to the negative 23rd. And what are our units? They are grams. That's what we were left over with after the conversion factors. Here is our final answer in scientific notation. And if we write this out in regular decimal notation, we can see that it is a tiny, tiny, tiny number. 2.66 times 10 to the negative 23rd grams. The mass of a single atom of oxygen. Okay, so the key to solving that problem was being able to take this information and write conversion factors with it, okay? We knew that 1 mole of oxygen weighed this much, and we know how many oxygen atoms are in 1 mole. So we could take that information and write these 2 conversion factors. It could let us go from number of oxygen atoms to grams and back and forth. What mass of mercury has the same number of atoms as 64.2 grams of calcium? I don't know about you, but I find the wording in this question really confusing. So I want to try to explain what they're actually trying to ask here so you can understand how to solve. Okay? So we got mercury and we got calcium. We can look them up on the periodic table, and this number here, the molar mass, tells us how much a mole of each of these types of atoms would weigh. Okay? So mercury here, we know that 1 mole of mercury atoms, 602 hexillion mercury atoms, would weigh 200.6 grams. And for calcium here, 1 mole of calcium atoms, 602 hexillion calcium atoms, weighs 40.08 grams. Okay? So here's the main point. The main point is that 200.6 grams of mercury and 40.08 grams of calcium both have the same number of atoms in this, okay? The masses are different. This weighs a whole lot more. This is a lot lighter. But the point is, even though the masses are different, the number of atoms is the same, because 602 hexillion mercury atoms weigh this much, and 602 hexillion calcium atoms weigh this much. Okay, so that we can say that this amount of mercury and this amount of calcium have the same number of atoms in them. Okay? What the question is really asking is sort of like X grams of mercury and 64.2 grams of calcium have the same number of atoms, right? That's not really a question, but it's a statement, okay? It's like, what amount of mercury has the same number of atoms as 64.2 grams of calcium? Okay, this amount of mercury and this amount of calcium have the same number of atoms. This amount of calcium and how much mercury have the same number of atoms, okay? So here's how we're going to solve it. We're going to do 2 steps. Step 1, we're going to ask how many atoms are in 64.2 grams of calcium, and then we're going to take that number of atoms that are in this amount of calcium, and we're going to ask, if we had that number of mercury atoms, how much would that weigh? So let's start here with part 1. Okay, so I'm going to start here with 64.2 grams of calcium. And now I want to figure out how many atoms are in that. So I'm going to multiply it by a conversion factor that I can make from this information here. I want to get rid of grams, so I'm going to put grams on the bottom. I'm going to do 40.08 grams of calcium. And then on the top, I'm going to put 6.02 times 10 to the 23rd atoms. Okay? So now we got grams calcium here, grams calcium here. They're going to cancel out. I'm going to be left with atoms of calcium. I can put this into the calculator. I get this out as my answer, and I'm going to round it to 3 significant figures. So I'm going to get 9.64 times 10 to the 23rd. Okay? 9.64 times 10 to the 23rd calcium atoms. This is how many calcium atoms are in this much calcium. Now the next thing that I want to do here is ask, if we had that number, if we had this number of mercury atoms, how much would that weigh? Okay, so we have this many calcium atoms. If we had that much of mercury, how much would that weigh? Okay, so here's how we're going to do that. We're going to take this and we're going to multiply it by a conversion factor that we can write from this information that tells us about how much a certain number of mercury atoms weigh. Okay, so we're going to multiply that by 6.02 times 10 to the 23rd. We can do Hg mercury atoms on the bottom, and then multiply it by 200.6 grams of mercury on top. And now mercury atoms on the top, mercury atoms on the bottoms cancels out. I'm left with grams of mercury. The math I'm going to do is this. I get this out of the calculator, and my final answer, rounded to 3 significant figures, is 321 grams of mercury. And that tells us how much mercury, what mass of mercury would have the same number of atoms as 64.2 grams of calcium.